Hey guys, it's Simon and welcome back to the LibGDX RPG tutorial series in Java, where we're now going to continue with our render system and integrating the objects from Tiled. So in the last part, we learned what is the ECS architecture pattern, how to use it with Ashley entity component system in LibGDX, and we implemented a render system and created some components which we did not use yet really. But now in this part, we are going to implement something, and in my opinion, the most important class in that project, which is the TiledService, which is then responsible to really load objects from tiles, then also create collision objects out of tiles, the triggering and all of that stuff is then happening, which is the connector class between the tiled program and LibGDX. So how does it work? A little bit of a history. So my last couple of games, I always used Tiled as my game editor with the, what's it called, the collection of images tile set, where, as I explained in, I think, parts 2 or 3, where I set the different properties with classes, enumerations, and so on, and then integrated that with LibGDX. And normally I also use Box2D as a physics engine for the collision handling and all of that stuff. So I always, let's call it hard-coded the specifics of the game inside that logic or in that integration with Tiled. So the problem was that when I worked on a new game, I couldn't simply take over like a utility class and then just adjust the things that I needed. I always had to write it more or less from scratch. I copied over certain parts, of course, that I implemented before, and did that then, or copied that or pasted that into the new class and then adjusted the game-specific things again. And this time I thought I tried to be a little bit smarter and create a generic solution for the tiled integration. So when it comes to really then doing something with an object here, so how to load the tree or the player, that one can be added as an, extension or whatever you want to call that, to that class that we are going to implement now. But the tiled-specific logic, like going through the different objects, reading the properties, all of that stuff, that is part of that core class. So the idea was, and I think I solved that, or it's working like that this tiled service that we are now going to implement, that can be simply taken over to different projects. And the game-specific parts, so configuring the entity, using Ashley or whatever other entity component system you want to have, that one can be then added as an extension to that core class and can be adjusted to the needs of whatever game you are going to implement. So that is the idea. Also, maybe I haven't released any parts yet, so I haven't read any comments yet because you couldn't write any comments yet. But some people might ask why I call that service classes and why I don't call them managers or whatever. The reason is simply that I work a lot with Spring in my daily job. And in Spring, you have these service annotation and service classes. So that's why I also just call those classes usually service classes. But call them manager or utils or utilities or whatever you want. That's the reason for the naming convention on my side. Okay, so we need a new package. Let's call it tiled, and let's create a new class that is called TiledService. So the TiledService, it takes care of a couple of things. So I write down first the method that we are going to implement. Then it's more clear what the purpose of this service is. So first of all, we need a method to load a map where we pass a map asset, and then we do something. Then we don't just want to load a map, we also want to set an active map. And there we take a tiled map, which gets returned by the load map method. So setMap is really setting the currently active map, and loadMap is just loading a map. That would be the distinguished part between here. And finally, we want to have one method which is responsible for loading MapObjects, which takes the TiledMap as an argument, and another method which is responsible for loading an object layer. Which takes a map layer, which is the object layer, and then it does something. Okay, so what does all of that mean? So load map, set map is clear. And then we are going to somehow pass the different or go through the different layers of our map. And when we find an object layer, which we will identify by the name, so the name is here objects, then we iterate through the different objects of that layer, which in our case, as you see here, we have a house, we have a couple of trees, and we have a player. And then for each of these objects, that is then this extension or plugin mechanism that I mentioned before, we are then going to call some custom code if it is registered. And then this custom code takes care of doing whatever it needs to do or what it wants to do with these objects. In our case, we will create entities for Ashley and add it to the engine. Good, so how does it work? So we definitely need access to our asset service because in the load map method, we need to load the tiled map. Then we need the tiled map itself, which is the current map, which is active. I think having a reference to that also makes sense. And now we are going to the custom code part. So there we have a consumer. I come to that also in a moment. That would be the map change consumer. So any logic in our game that needs to react to map changes can be done via this consumer, and another consumer which takes a TiledMap object. That is most likely the longest object name that we will ever have. Typical Java class name. That is the load object consumer. Again, here, why do I have here consumers? For me, there are two strategies to solve that. You could have the typical observer pattern approach. So where we have listeners, then you can register as a listener to this TiledService class, and the listeners then simply implement a specific method, which then gets called by this TiledService. And yeah, would be one approach, but I always find that a little bit tedious to have then a list of listeners, then you need to edit there, iterate through that list. And I found that in most of my games, I almost never need to remove a listener because I just, when for example, the GameScreen gets created, I tie everything together. So register all the different listeners, for example, to the TiledService. And that's it. It almost never changes. So I don't need to remove a listener dynamically. So that's why I wanted to use, and I find it easier to write. It's shorter. I wanted to use the consumer parts, which was introduced, I think, in Java 8, if I remember correctly. And then with the special syntax, there's consumer 1, and then consumer 2, and then consumer 3. So with something like that, we can create a chain and also have a specific order of what kind of logic should be executed when. So that's the reason why I used here consumers instead of the typical observer pattern approach with the listeners. Okay, for the tiled service, we need a constructor where we get the asset service and assign it. And our map change consumer initially is null. And our load object consumer is also null, and our current map is null. Good. When we load a map, there we can take over the code from our game screen. It's just one line. Let's remove that for now. So we are going to load the map, which is the tiled map, and we are also going to return the tiled map at the end. Additionally, what we want to do, that's in the set map. So if there is a current map, so if it's not null, then we are going to unload it. So from our asset service, I think we don't have the unload method yet because we didn't need it, but now we are going to need it. And from the properties, we get, I explain in a moment what that is here, we get the map asset class. Let's implement this unload method quickly. Let's move it up here. So what we get here, we get an asset type T, an asset, and then from the asset manager, we unload this asset, and I'm not 100% sure. Maybe we need to call finish loading. Let me quickly check. No, we don't need that. So just from the original asset manager in LibGDX, we call the unload method with the asset descriptor. And of course here we need the generic T. Good. So how does that work? So what does that mean? The asset manager itself always works with file names, or in our case with our asset enumerations. And the normal TiledMap doesn't have this information. So it's just the TiledMap from LibGDX. But we can add this information because I showed it in the debugger. In the debugger, if I don't forget that, a lot of objects when it comes to this TiledMap part in LibGDX contain specific properties, which is simply a map again with key value pairs. And yeah, we can store here the map asset information in the map with that specific key. So this map asset enum gets stored in this TiledMap instance. And I forgot to set the current map below here. So this current map equals map. So if the current map would be already loaded, then we unload it via that property that we set here. So this is how it's working. Okay, and after the current map, we are going to load the map objects of this tiled map, of the map that gets passed. And also if the map change consumer is specified, so if a class needs to react to map changes, like our render system, which we're also going to adjust, then we call here the map change method of these different consumers. That's this part here. Good, so the only thing that we are missing currently is the load map objects. And here, so we have our tiled map. A tiled map has a list of the different layers, and we can iterate over these layers. And now, as mentioned, we compare by name. So if objects is equal to the name of the layer, then we are going to load the object layer. Okay. So for now, this loop could be written differently and easier, but later on we are going to add here some other parsing as well for a trigger layer and maybe some other layers. I cannot remember 100%. So there will be additional branches in here in this loop. For now, we just have this one. So you might think that's a little bit of an overkill, could be written differently. But yeah, again, later on, there will be some other cases that we add here. So that's why we have the for loop here with the check. And yeah, let me quickly check that. So objects is the name of the layer. Yes, so objects here, that's the layer name. That is the one that we are comparing here in the code. And yeah, when we have that, then we are going to load the object layer. And here, so if we have load object consumer null, then we don't need to do anything because there is no custom code registered to our service class. So nothing special needs to happen and we can simply abort. Otherwise, if there is something registered, then we get the different objects of that layer with layer get objects. Again, we can loop over it. And let's call it map object. Okay, and there are different kind of map objects. The one that we are interested in is the TiledMap object. TiledMap object. And yeah, if we have one like that, then we call our load object consumer for it. And otherwise, what I like to do here, so if we have a different kind of object placed in Tiled, we want to know about it, that something is not supported yet. So we throw a GDX runtime exception, unsupported object, with map object get class, get simple name. Okay, so what kind of other map objects are there? So the TiledMap object, the names are really crazy, are these objects here where the object references a tile of the tile set. But there would also be, for example, rectangle map objects that we later on use for trigger, for example. Then there would be, is it called point objects? I think that would be a point. Then there are also circle or ellipse map objects. There are polyline and polygon map objects. And I think that's it. But for now we are, there's also the text map object. I forgot about that one. But for now, we are just interested in the tile map object. So that's why in our code, coming back here, we just iterate through all the objects. We check, is it a TiledMap tile object? And if yes, then we call the custom logic. And I think that's it for our tiled service. So we have a consumer for map change. We have a consumer for the different map objects. We can load a map. Oh, by the way, here we need to pass in the map assets that we pass from the method and not the hard-coded main assets. Then we can set an active map, which also unloads it from the asset service. Here, most likely you also in a real game want to clean up the entities, maybe save the state of the entities which are remaining on the current map, things like that. For now, we would just remove the asset from the asset manager and that's it. Okay, so let's use this service now in our game screen. So first of all, let's get here a tiled service instance and pass in the asset service. Also, we will adjust it in the render system. In the last part, I passed here the asset service, but actually we want to pass here the camera, which is a little bit better code-wise than what we had before. We fixed it then in a moment. For now, we are interested in the tiled service. So here we are creating the new instance. And now in our show method, we want to do it a little bit differently. So we still want to get the render system. And from the render system, we want to have the set map, which is a consumer of a tiled map. And let's call that the render consumer. Okay. And now in our tiled service, we set the map. Oh, we don't have a method for that yet. So let's add the setters here as well. So set map change consumer and set load object consumer. Okay, so set map change consumer would be our render consumer. And later on, we might add additional systems which need to react there. Then we can add the different consumers with and then, and have a specific chain and order of how the custom logic will be called. For now, it's rather simple. It's just this render consumer. Okay, and also at the end, when everything is configured, we want to load the map, which is the main map in our case, but we do that now with the tiled service, and we set the active map also like that. Okay, so let's adjust the render system. Add here the constructor argument. Let's have here a reference to the camera as well. We already have that. So here, down here, this camera equals camera. So then we don't need the cast from the viewport. then we have it like that. It's a little bit nicer. Good, so in theory, can we test it already? I think so. So we now have the tiled service. That one should call this map here. So I remember now that I wanted to show you something in a debugger. So I set here a breakpoint and let's see if everything is working. So we have here set map. And we see the tiled map. So our service at the consumer integration is working perfect. Now I want to show you a little bit the TiledMap class itself, because we used a couple of things in the tiled service, which was maybe a little bit too fast. So in LibGDX, we have the TiledMap, which is the object for the TiledMap. And a TiledMap has references to the tile sets. It has a reference to the different layers. And as I mentioned before, it has properties. As you can see here, it has, for example, the map asset that we added, which is main. It also has a music property. Because I copied it from the GitHub repository, we didn't add that there. So you don't have this music property, ignore that. It has a tile width, height, and so on. These are some basic properties which get set by LibGDX. Then again, it has access to the different layers, which is just an array. The first is a TiledMap tile layer. Then the third one is just a map layer with the name object. So that would be our object layer. A layer again has then a reference to its objects itself, which is again an array. In our case, it has 6 items, which are all TiledMap objects with a specific graphic, or they have a reference to a tile. The tile has a texture region and things like that. So there you see a little bit how the data structure of a tiled map, the different layer and the tile sets and so on is working. So that's the power of the debugger. If you didn't know, this is how I usually try to understand and debug things of the library in LibGDX, for example. Good. So that one is working, which is great. Now we need to create entities. We haven't created entities yet. And the way I did that, so as mentioned, we have the TiledService class, the core class, which has some common functionality when it comes to the integration with Tiled. But I did not want to add here game-specific logic, like creating entities with Ashleys and so on. For that, I created a separate class, which I called in the repository, I think it called it TiledAshleyConfigurator or something like that. The name is maybe not the best one, but I think it's called like that in the repository. And this class then basically now contains the custom logic for our game. And in our case, we are going to implement the custom logic, a very simple one, to load these objects, the tree, the house, and the player as an entity in Ashley. So what we need a method, let's call it onLoadObject. That is the consumer method, which takes a TiledMap tile object. And in here, we now add the custom code that we need, that we want when an object in tile should get loaded. So what we need, since we are creating entities, we need access to the ECS engine. And later on, we also need access to specific assets. So that's why we also need access to our asset service. Then let's create the constructor. Okay, now when we get this object, what do we want? First of all, we want to create an entity. Okay, and at the end, when all the configuration is done, then we add this entity to our engine. So this is how entity creation works in Ashley. Then from the TiledMap tile object, we need to get access to the tile. And we need the texture region for rendering. There we are going to implement a method, get texture region, where we pass in the tile. Okay, so how does that work? Again, might be a lot of information, so I try to break it down a little bit. We have an object in Tiled, like the player. The player object here is linked to a tile in our tile set. And the tile set here, this is the tile. This one has a texture region, which is the image reference here, and some other properties. So this is how it's working. And yeah, so let's implement this method here, the texture region, which is currently a very, very simple method because we just return the region of the tile itself. Later on, we will improve that because when it comes to rendering, just to quickly mention that, what will happen, we render the map and then we will render the different objects for now. And since the graphics for the player, tree and the house, they are all separate images, we will have separate draw calls. Later on, we optimize that and combine all these images into a so-called texture atlas, which is very simple, just a big graphic which contains all the graphics that you see here to reduce the amount of draw calls back to just one draw call for all the different objects instead of one draw call per object. But for now, we don't do that yet. That will be the next part with the optimization. In this part, we focus on that specific logic here. So we simply return the texture region of the tile itself. Good. And the last part would be the set index of our transformation. So there, if we want to have a specific object, maybe always in the background or always in the foreground, we can use the set index as an optional argument. So from the tile, we get the properties. We get the property with the name set. If it is not available, we use the default value 1. And otherwise, we get the set property of the tile. Okay, and now we just need to configure the entity. And yeah, the way it's working is that simply for the entity, we call the add method to add the component. And now let's create, for example, a new graphic component, which takes a color, which would be, let's take the color white, and we copy that. That is important because the color object, unfortunately, LibGDX, it's mutable. So if we would pass in here the color white and maybe at some point modify the color of the entity, then we would actually adjust the color white here, which of course we don't want. So that's why we create a new white color with the copy call here to have a separate reference. And yeah, the second argument is the texture region. And the second component that we have is the transform component, which has quite some arguments. So first of all, we have a position. So vector 2. From our TiledMap object, the x coordinate, then from our TiledMap object, the y coordinate, then the set index, then the size, if I'm not mistaken. Yes, the size, which is also a vector 2. Here we have the texture region get region width and texture region get region height. So simply the size of the graphic will be the size of the entity to keep it here. Very simple. Then we have the scaling, which, yeah, let's not scale it for now. And we also don't want to have a rotation. So we just have here a rotation of 0 degrees. Okay, so as you can imagine, so the more components we add, the longer this method gets, and it might be not always as trivial as here to simply create components like that. So the approach that I usually prefer here is that for a little bit more complex components, I create separate methods. So for example, add entity transform, and there I pass in then the different arguments. And for example, here, let's create this method. And inside this method, I then create the component. And transforming, actually, if we would create the transform component like that, like I did it here, that would be wrong because, let me show you an example. So for the player, do I somehow see its position? Yes. So position would be 9 and Y would be 231 because the position in here is in pixels, and also it's from top. So from top to bottom here, it's 231 pixels. And that is, of course, not how it works in our game, because if you remember, we want to have our abstract world units. We don't care about pixels or anything. So that's why we need to scale everything with our unit scale constant. And that's why we need some adjustments here. So let me quickly adjust this method here. Again, I think it's rather boring for you to watch me doing it. And then I simply guide you through what we did. Okay, so it looks like this. So at entity transform, we pass in the X and Y coordinate of the map object, the Z index, then the region width and height for the size, the scaling of the map object, and the entity itself that we want to modify. And below here, so we create then the position, the size, and the scaling like we did it before. But now we scale the position with our unit scale, we scale the size with our unit scale, and pass that one to our transform component. And I think that's it for now for this TiledAshleyConfigurator. So what we need to do now, back in our GameScreen, we need our TiledAshleyConfigurator, where we pass it the engine. So I need to move it down one line, and the asset service. And in addition, in our TiledService, we want to set the load object consumer, which is from the TiledAshleyConfigurator, the onload object method. And theoretically, that should be everything that we need. Okay, so I forgot something. So in our render system, currently the rendering won't work because I haven't finalized the update method properly. So what is happening? We have here the rendering of our TiledMap, where if you remember correctly, we have begin batch and end batch. And actually now when we come to our entities in here, we get an error because we call the draw method of the batch, but we didn't call batch.begin. So there's something missing, and this update method here is not finalized yet, and we want to optimize it then. But the optimizations are happening in the next part. So for now, to keep it simple, I think the only thing that we need to do is that here, maybe after the sorting, here we call for now batch begin. Here we call batch.end. Also, we don't need to restore the color because that's happening here at the beginning. So that should be okay. And when we render something, we also need to, how's it called? Set projection matrix, if I remember correctly. And that would be the combined matrix of the camera. Let me quickly check in set view. Batch, set, protect, combined. Okay, so that is one important piece of information. Maybe I didn't mention that yet. When you start rendering in OpenGL with the sprite patch, in that case, you need to pass it a specific matrix. It's a 4x4 matrix, if I remember correctly. Yeah, matrix 4, which in mathematical terms, it contains the information of where are you located in your world? Where are you looking at? Are you zooming? Do things need to get scaled and things like that? So before you start rendering, you always need to set this projection matrix. In our case, it's already happening inside the set view. So we don't need to call it here again, actually. That's not necessary. But we need the begin and end call of the sprite patch so that our entities get correctly rendered. And now I think it should already work. And yata, it seems to work. So we have here our player, which is in front of the tree. So the sorting also is working correctly, that the player is really in front of the tree. We can change that, I think, quite easily to see if something, if it's broken, if it's not working. So let me quickly go to the transform component and maybe return here. I think if I just swap it around, is it like that? Then it's already the other way around. Yes. So now you see the tree is in front of the player, so it's here cut off. So the sorting would not be correct here. We also see that the sorting is actually working and happening. And yeah, let me revert the change. So all of that is good, so perfect. So now we have the TiledService. We have a very generic solution also for future games. And at the moment, we just added the custom logic to load MapObjects, which for now they are rather simple. It's just a graphic and a transform component. And that's it. But throughout the tutorial, we will add more and more components and more functionality to the game. But for now, that's it. And in the next part, that should hopefully be a little bit of a smaller part, we are going to optimize the rendering, because as you see here, we now have 6 draw calls and we want to bring that down ideally to just 1 draw call, which most likely is impossible, but down to 2 or maybe 3 draw calls. So there we will do some optimizations with our rendering pipeline here. Thanks for watching and have a nice rest of the day. Bye bye.